Let's talk about one of the coolest concepts in biopharmaceutics and pharmacokinetics, the principle of superposition. This principle might sound a bit complex at first, but don't worry, we'll break it down and make it super easy to understand. So the principle of superposition is a rule used in pharmacokinetics that helps us to figure out what happens to drug levels in the body when we take multiple doses over time. And the best part is it assumes that earlier doses don't affect the pharmacokinetics of later doses, subsequent doses. This means that the concentration of the drug in your blood after each dose is just the sum of the concentrations from each dose. So no dose changes the way the drug behaves after the first one. Let's see the basic concept of this principle of superposition. So when a drug follows linear pharmacokinetics, that is distribution, metabolism and excretion are all first order. Okay. The total concentration at any given time after multiple doses is simply the sum of the concentration from each individual dose. Okay. In other words, each dose adds its own concentration curve without changing the others. The curves are superimposed. We will see in the graph. Before we go further, let's quickly go over the assumptions behind this principle. The first one is first order elimination kinetics. This means the drug is eliminated at a rate proportional to its concentration. The more drug you have, the faster it gets eliminated. The second one is pharmacokinetics remain unchanged. This means the drug behaves the same way in the body after the first dose as it does after the second, third and so on. Third one is no drug-drug interactions. It means the drug does not alter its own metabolism or clearance over time. And the fourth one and the last one is linear dose concentration relationship. If you double the dose, the concentration in your blood will double. So these assumptions are crucial because they allow us to predict what happens when you take multiple doses. If any of these assumptions are violated, this principle does not work. So keep that in mind. Now let's talk about how this principle actually works. First one, single dose study first. Okay. Imagine you take one dose of a drug. You then measure how the concentration of the drug in your blood changes over time, which will give you plasma concentration time curve. This curve shows these parameters, pharmacokinetics parameters. C naught is initial concentration, Vd is apparent volume of distribution, K is elimination rate constant, T half is half-life, Cl is clearance. This curve is crucial because it tells us how the drug behaves in the body after first dose. From this, we can calculate pharmacokinetic parameters, which we will use to predict what happens in multiple doses. Now, the second one is multiple dose prediction. Now, what happens if you keep taking doses of the same drug at regular intervals? Okay. According to the principle of superposition, the drug concentrations, okay, after each dose will simply add together. Okay, they will get added up. So if you take the first dose and measure the concentration and then take the second dose, you add the second concentrations from both doses at any given time. Think of it like stacking up layer of something. After the second dose, the concentration is the sum of the first dose concentration. and the second dose concentration. And when you take the third dose, you add the concentration from the third dose to the total. So the concentration at any time is the sum of all previous doses. This gives us the total drug concentration in the blood, and we can predict this using principle of superposition. Don't worry, if you see the graph, you will get understand. The third one is steady state. Okay, here is the cool part. If you keep taking the drug at regular intervals, you eventually reach something called steady state, at which rate of drug input is equals to rate of drug elimination. At a steady state, the amount of the drug going into your body, that is input, from each new dose, which will be equal to the amount of drug being eliminated. So the concentration in the body stays constant. When this happens, the plasma concentration curves from each dose will overlap, okay, perfectly. This means that after a few doses, you will see the same peak and throw for each dose, and they will stay constant. Here is an example to illustrate. Let's say you are on a medication that you have to take every 8 hours. The first time you take the drug, the concentration starts rising, peaks, then it gets decreases. But when you take the second dose and from the first dose, the concentration is still in your body. So when you take the second dose, the concentration from the first dose adds to the concentration from the second dose. This process continues with the third and fourth doses. Over time, the concentration will reach a point where each dose just adds to the existing concentration and you will have a steady state. Once you hit the steady state, the concentration becomes predictable and it's easier to manage the dosing to maintain the drug in the therapeutic range. The principle of superposition is extremely useful because it predicts drug concentration after multiple doses without needing to measure every dose. It helps designing dose regimen. Okay, dose regimens based on single dose studies. For example, if we know how a drug behaves after a single dose, we can predict what happens when you take it multiple times. It ensures drug levels within therapeutic range, which is crucial for effective treatment. It is useful in therapeutic drug monitoring, that is TDM, and dose adjustment. But remember, the principle does not work if the drug follows nonlinear kinetics. For example, drugs like phenytoin or ethanol show saturation kinetics, meaning at higher doses their elimination rate does not follow the same pattern. In these cases, adding up concentration from each dose does not work. So, while the principle of superposition is super helpful, for most drugs, it won't apply to drugs that show nonlinear pharmacokinetics. So here is the graph. We are taking plasma drug concentration and time in hours. Okay, the black line indicates total concentration and the orange line indicates dose 1 and the blue line is the dose 2 and green line is dose 3. So after a certain point at steady state, okay, at steady state, the peaks and throws after each dose are the same and superimposed. Here you can see. So to wrap it up, the principle of superposition is a simple, powerful concept used to predict drug concentrations after multiple doses. Here is the key takeaways you can note down. The principle assumes that the drug follows first order elimination kinetics, okay? The concentration after each dose are simply added together to get the total drug concentrations. And the third point is it helps to predict steady state concentrations, designing dose, schedules, and maintain drug levels in the therapeutic range. And that's it. The principle of superposition is essential for understanding how drugs behave when taken repeatedly. It makes predicting drug levels and designing dosing regimens much easier. Remember, superposition, which will be equal to adding concentrations from each dose. Steady state is equals to when drug inputs is equals to drug elimination. If you have any questions, feel free to ask in comment section.